We're not done yet because our question wanted to know how far below the point of release is the bottom of the crevasse. This means what is the distance when t equals 30? Using our new function f of t, we plug in 30 for t. Is negative 0.8 times 30 squared. Through calculator magic, we find negative 720 meters. This means we're 720 meters below where we dropped it. So the crevasse is 720 meters deep. This brings us to part C. Part C tells us instead of being released from rest, the rock is thrown into the crevasse from the same point with a downward velocity of 4 meters per second. This downward part matters. When will it hit the bottom and how fast will it be going when it does? When will it hit the bottom is going to ask us for time, and how fast is asking us for velocity. We still have the same acceleration due to gravity, negative 1.6. Velocity, we use the same process, but we're going to have a different c term because we're going to use the point 0, negative 4. Because at 0 seconds, when we first throw this rock, the rock is already traveling downward at 4 meters per second. We plug point P in. Negative 4 equals negative 1.6 times 0 plus c. c equals negative 4. We now have that f prime of t equals negative 1.6 t minus 4. This gives us velocity in terms of time. The first part, though, is asking us, when will it hit the bottom? Well, we don't know how much time it will take to travel at this new velocity. We do, however, know that the crevasse is 720 meters deep. Well, let's find our distance function. We have f of t. We're going to take the antiderivative, is negative 0.8 t squared minus 4t plus c. Again, we'll say that we're starting from 0 meters, which will make c equal to 0. So f of t equals negative 0.8 t squared minus 4t. We know that the distance equals 720 meters, negative 720. We want to find what t would be then. Plug in 720, solve for t. We can move everything to the left side. 0.8 t squared plus 4t plus 720. Oh no, it's minus because we have a negative 720. There we go, that's a lot better. Equals 0. You can use the quadratic formula to solve for t. You find that t is either going to be negative 32.61 or 27.61. And just quickly remember the quadratic formula is negative b plus or minus square root of b squared minus 4ac all over 2a. That's how I found those values for t. Well, clearly the negative time doesn't make sense, which means we hit the bottom after 27.61 seconds. Okay, we have one more part to our question. We want to know how fast will this rock be going when it hits the bottom. How fast is a velocity, which means we will use our velocity formula. F prime of t equals negative 1.6 t minus 4.